So, you're building a piece of software. Could be a tiny mobile app, could be a massive global service. Doesn't matter. From day one, you are going to be absolutely flooded with choices. And here's the big secret. The one thing every great engineer really understands, every single one of those choices is a trade-off. It's the most important concept in system design, so let's really get into what that means.
And this is it. This is the one rule to rule them all. There's no magic bullet, no single best way to build anything. Every time you make a decision to get an edge in one area, say, making it faster, you're almost certainly giving something up in another area, like how well it can scale or how consistent the data is. So mastering system design is really just mastering the art of the trade-off.
All right, so in this explainer, we're going to break down the 4 main battlegrounds where these trade-offs are made. First, how you handle growth and scale. Then, the dilemmas you face with your data. After that, we'll get into architecture and how the pieces talk to each other. And finally, we'll talk about how you put it all together to actually make the right call.
Okay, let's jump right in with the first major hurdle every successful system slams into eventually: growth. The moment more people start using your thing, you've got a big question to answer. How do you keep it all running smoothly without everything just falling over?
You've basically got 2 moves you can make. On one side, you can scale up, which is vertical scaling. Think of this like taking your one server and making it an absolute beast. More CPU, more RAM, the works. It's simpler for sure, but what happens if that one giant server goes down? Game over. The other move is to scale out, or horizontal scaling. Here, instead of one big server, you just add more and more smaller servers to share the work. It's how huge services like Google or Facebook operate, but it's also way more complex to manage. And this chart just nails the core difference. When you scale vertically, you're always going to hit a hard physical wall. You can only cram so much memory or processing power into a single box. But with horizontal scaling, well, in theory, the sky's the limit. You can just keep throwing more machines at the problem to handle pretty much any amount of growth.
But scale isn't just about handling more users, it's also about performance. And guess what? Performance is also a trade-off. You have to decide, are you optimizing for latency or throughput? Latency is all about the speed of a single request. Think about an online game. Every millisecond counts. Throughput, on the other hand, is about the total volume you can handle over time. Think about a system crunching massive amounts of data for analytics. Trying to maximize one often means the other takes a hit.
Okay, so we've handled growth, but what about the data itself? This is where some of the most critical and honestly the trickiest trade-offs in all of system design are hiding. It all boils down to how you choose to store and access your information. So, the first big choice is your database. On one side, you've got SQL databases. These are super structured, very rigid, kind of like a perfectly organized spreadsheet. This is absolutely what you want for something like a bank, where every single transaction has to be perfect. On the other side, you've got NoSQL. These are flexible, they don't really care about a strict structure, and they're built for insane speed and scale. It's why they're perfect for things like a recommendation engine. You're basically trading rigid structure for massive scalability. Now, the moment you have data living on more than one machine, you run headfirst into a fundamental law of the universe, or at least of distributed systems. It's called the CAP theorem, and it says you have 3 things you want. Consistency, where everyone sees the same data at the same time. Availability, meaning the system is always responsive. And partition tolerance, which means it keeps working even if parts of the network fail. The catch? You can only pick 2. Always. So the question becomes, what are you willing to sacrifice? If you're building a bank's ledger system, consistency is non-negotiable. You would rather the system go offline for a minute than show someone the wrong balance. So you sacrifice availability. That's a CP system. But what about a social media feed? You'd much rather the site stay up and running, even if it means a friend's latest photo takes a few extra seconds to show up for everyone. In that case, you sacrifice a bit of consistency for availability. That's an AP system. You have to make the choice. And that leads us right into this idea of consistency models. Strong consistency is that banking example again. The moment an update happens, every single person who reads that data sees the most recent version. Period. Then there's eventual consistency. This just means the system will, well, eventually catch up. That photo you just uploaded will get to all your friends, just maybe not in the same millisecond. And that's totally fine for most apps, and in return you get a huge boost in performance and availability. So we figured out how to scale our servers and manage our data, but how do all the different pieces of the actual application fit together and talk to each other? Now we're getting into the big picture, the architecture.
And here we have the classic debate. Do you build a monolith where everything, your user interface, your business logic, your database access, is all in one giant single codebase? It's way simpler to get started with. Or do you go with microservices, where you break your application up into dozens or even hundreds of tiny, independent services? This gives you unbelievable flexibility and makes it easier to scale individual parts. But man, does it get complicated to manage all those moving pieces.
But here's the thing to remember. This choice isn't forever. In fact, there's a really common path that tons of companies follow. You start with a monolith because you need to move fast and just get your product out there. Then, as you grow and the monolith starts to get clunky and slow you down, you begin the long, complicated process of breaking it apart into microservices. And finally, how do things actually get done inside the system? Synchronous processing is like standing in a single file line. You have to wait for the person in front of you to finish before you can go. Think about clicking Pay Now on a website. You sit there and wait for that confirmation screen. Asynchronous processing is different. It's like sending a text message. You send it, then you put your phone away and do other things. You'll get a response later. This is exactly what happens when you upload a photo to social media. The upload happens in the background while you keep scrolling. Okay, we have covered a ton of ground. We've talked scaling, data, architecture. So with all these competing forces pulling you in different directions, how in the world do you actually make the right call for your project? This is it. This is the question every single engineer wants the answer to. Vertical or horizontal? SQL or no SQL? Monolith or microservices? Just tell me, what's the right answer? And here it is, the big secret. The answer is, there is no best answer. It doesn't exist. There is only the right trade-off for your specific project, for your specific users, and for your specific team. Context is absolutely everything. So, why do you need to take away from all this? First, just remember that nothing is free. Every decision you make has a plus and a minus. Second, before you do anything, figure out what you care about most. Is it blinding speed, massive scale, or bulletproof consistency? Define it first. Third, remember that the right choice today might be the wrong choice a year from now. Your architecture has to evolve. And finally, just embrace it. System design isn't about finding some perfect, elegant solution. It's an exercise in intelligently balancing all these competing forces to build the best possible thing you can right now.